Hi everyone, my name is Sabina Gera and I will briefly tell you something about the topic chemical, toxic and radioactive properties of depleted uranium, which is processed within the Model 2. I will say something more about radioactivity of depleted uranium, with a special reference to radiation, as well as the radioactivity of depleted uranium with the reference to whether depleted uranium is a radiation hazard. Radiation can be defined as energy that is transmitted from one location to another in a form that can be described as either a wave or a particle. We are exposed to radiation on a daily basis as a part of our everyday lives. The implementation of appropriate measures is necessary to safeguard the body and the environment from the potential adverse effects of radiation while facilitating the utilization of its numerous applications. All naturally occurring uranium isotopes are known to emit alpha particles. Uranium isotopes undergo a process of radioactive decay, leading to the formation of stable lead isotopes. During the decay process, beta and gamma radiation is emitted. Beta particles have a greater capacity to penetrate the skin than alpha particles, while gamma rays are highly penetrating and can present both internal and external. What is radiation? What is non-ionizing radiation and ionizing radiation? Non-ionizing and ionizing radiation have different wavelengths which directly relate to its energy. Non-ionizing radiation is defined as a form of electromagnetic radiation with a lower energy level than that is insufficient to dislodge electrons from atoms or molecules, whether in matter or in living organisms. Nevertheless, the energy of the radiation can cause the molecules to vibrate, thereby generating heat. This is, for example, the mechanism by which microwave ovens operate. For most people, non-ionization radiation does not pose a risk to their health. And what is ionizing radiation? It is a form of radiation with sufficient energy to dislodge electrons from atoms or molecules, thereby initiating changes at the atomic level when interacting with matter, including living organisms. Such changes typically entail the formation of ions, electrically charged atoms or molecules, which is the basis for the term ionizing radiation. In high doses, ionizing radiation can damage cells or organs in our bodies or even cause death. Ionizing radiation can be generated by unstable radioactive atoms as they undergo a transition to a more stable state, releasing energy in the process. Since we are depleted uranium, we should also define gamma radiation. Gamma radiation is a high energy short wavelength form of electromagnetic radiation emitted from the nucleus of an atom. Gamma radiation is frequently accompanies emission of alpha particle and beta particles and is always emitted in conjunction with fission. Gamma rays are similar to X-rays, but are highly penetrating and are best stopped or shielded by dense materials such as lead or depleted uranium. What should we need to know about radioactivity of depleted uranium? Its level of radioactivity is lower than that of natural uranium. all traces of radioactivity, decay products beyond uranium 234 and thorium 231, have been removed during the extraction and chemical processes of the uranium prior to the enrichment. The specific activity of uranium is depleted uranium. In depleted uranium is the 14.8 becquerel per milligram compared with 25.4 becquerel per milligram for natural uranium due to the partial removal of uranium 234. It should be noted that not all uranium-234 is removed in the separation process, and the exact concentration remaining in the depleted uranium depends on the characteristics of the separation plant and the required yields. In the event that depleted uranium is produced by the enrichment of spent reactor fuel rods, the additional radioisotopes present in the depleted uranium results in an overall radiation dose that is increased by less than 1%. It is deemed that this supplementary radiation dose does not give rise to any additional radiological consequences. The question is also, what can we say about depleted uranium as a radiation hazard? The distinction between natural and depleted uranium is based on the relative concentration of uranium isotopes present. The level of radioactivity in depleted uranium is about 60% that of natural uranium, reflecting the removal of the more radioactive isotopes. All three naturally occurring uranium isotopes emit alpha particles as their primary form of radiation. Given that alpha particles are unstable to penetrate the skin, uranium is typically regarded as an internal radiological hazard rather than an external radiation hazard. It is important to maintain awareness of the external hazard, as depleted uranium can contain trace amounts of uranium-236 and other substances such as plutonium and technetium and americium. However, the risk posed by these trace contaminants is typically regarded as insignificant. A common misconception is that radiation is the primary hazard depleted uranium poses to human health. However, this is not the case under most exposure scenarios. Although irradiation from depleted uranium can occur, toxicity is typically the primary hazard associated with the soluble forms of uranium, whereas the radiological hazard is more pronounced in the case of inhalation of sparling soluble forms. Given that all forms of uranium exhibit identically intrinsic chemical characteristic, they also manifest analogous patterns of chemical toxicity. And if internalized, they all induce comparable adverse health effects to those observed in other heavy metals such as lead and cadmium. Uranium 138 radioactivity is low but cannot be neglected. Any empty device that contained radioactivity sources or was a LINAC needs to be examined to see if the device or its components contain depleted uranium. Depleted uranium is often contained in the radiation shielding of sealed radioactive sources in a wide variation of applications, including agriculture, medicine, industrial applications, transport, as well as other technical and research areas to protect users from radiation. The radioactivity of uranium 138 is relatively low, yet it cannot be disregarded. Depleted uranium is frequently incorporated in the radiation shielding of sealed radioactive sources, which are utilized in a multitude of applications, as I said before. Uh, and to conclude, this serves to safeguard users from radiation exposure. Thank you for your attention.